Hey guys, so today what I was going to do is trying to get this thing straight. I am going to go through the review for the test that y'all are going to be taking today. I think I have the wrong paper here. Okay, sorry there. So I've got your conservation, momentum, collisions, and impulse worksheet, but really it's your test review, and I'm going to go through just all the even numbers, and hopefully that will shed some light on your study progress. Okay. Number 2 says a force acting on a 5 kilogram body increases its speed uniformly from 2 to 8 meters a second through 5 seconds. Okay. So, what is the initial and final momentum? So, P initial and P final. Well, we know that momentum is simply mass times velocity, in this case, initial. And final is same thing, just velocity final. It's the only difference. Okay. So, our mass, we know is 5 kilograms. Times velocity initial, it started at 2. So 5 times 2 is 10. 10 kg ms. And that's it. Our final, 5, mass doesn't change. In this case, final velocity is 8. 5 times 8 is 40. What impulse did the body receive? Okay, so we know that impulse is J. We don't know force and we don't know time, right? So we can't use force times time. Oh, by the way, we know there's two triangles that we're going to be using throughout this whole thing. The two triangles are J is force times time, J is impulse. And we also know that momentum is mass times velocity. Okay, so if you cover up the P, you know that P is mv. If you cover up the M, you know that mass is P divided by V, momentum divided by velocity. If you cover up the J, it's force times time, but we also know that J is change in P, which is mass velocity final minus mass times velocity initial. Well, we already know what those two were. We found mass velocity final is 40 minus 10. So 40 minus 10 is 30, and our unit is still kilogram meters per second. Okay? What is the net force acting on it? Okay, so force is what it's asked for. If we cover up force, it's impulse divided by time. Force equals impulse, J, over time, T. We know that the impulse was 30. We know that the time was 5 seconds. So we get 6, and it's force, so we talk about force in newtons. How long must a 50 Newton force act on a 400 kilogram mass to raise its speed from 10 to 12? Okay, so on this one, how long, right? T equals time, okay? Time over here, J over F. Okay, so we know that force is 50 newtons. Okay, what's J? Uh-oh, well, we're going to have to figure that out. We know that J is change in velocity or change in momentum, mass velocity final, my pen's dying, minus mass times velocity initial. In this case, mass is 400. I'm not supposed to do number 3. Number 3 is not an even number. Doggone it. Oh well. 400 times the final velocity is 12 minus 400 times 10. Okay, over 50. So if we evaluate the top, 400 times 12 minus 400 times 10, that's a difference in 400 times 2. So we get 800 over 50 equals, otherwise you just type in the calculator. That didn't make sense. 16 seconds. As promised, I'll go through the even numbers. I did do number 3. You're welcome. A 75 kilogram skateboarder is initially going 5 meters a second to the right and slows down to a stop over 10 seconds. What is the direction and magnitude of the net force causing this change? So the direction, first off, direction If he's going to the right and he slows to a stop, well, the direction of the force would be to the left. Don't say to the south because it only told us to the right. Right? So right is the opposite of left. So left is the direction of the force. Next, magnitude. Okay, so now we're just trying to find the net force. Okay, magnitude of the net force. Force equals J over T, right? If we cover up F, remember from earlier, impulse divided by time. So what's our impulse? Because we know our time is 10 seconds. It's our impulse. He's initially going 5, but then he slows to a stop. So we have to find mass velocity final minus mass velocity initial, just like we did above. Mass, 75, times velocity final. He slows to a stop, 0, minus initial, 75 times 5. We'll divide all that by 10. What's 75 times 5? 75 times 5 is, what, 375 or something like that? 75 times 5, 375. There it is. 375 divided by 10 gives us 37.5 done. And force is measured in newtons. Okay. There's that one. Part B: if the skateboarder had to stop over 2 seconds rather than 10 seconds, what would need to be the direction and magnitude of the net force? Okay, so basically we have, this is 375 on top, right? So that's the impulse. Instead of dividing by 10, we divide by 2. Okay, 375 divided by 2 will give us 187.5. And force. And force is measured in newtons. Our direction would be left. Notice right here, there's actually negative 375, right? So that'd be negative, but the negative tells us that it's left. Okay. Okay. Anyways, so direction is left. Magnitude is just the 37.5, the number. Magnitude is always the number. When we changed the time over which the skateboarder had to stop, did the impulse experienced by the skateboarder change? No. Why not? Because the initial and final momentum were the same. Not were the same, didn't change. Okay? So, since they didn't change, then your impulse doesn't change. That's number 4. Number 6. A 3 kilogram tennis ball, 0.3 kilogram, is going west at 4 meters a second, bounce off a wall. After it's bounced, it's traveling east at 2. It was in contact with the wall for that time. Was kinetic energy conserved? Oh man. Okay. So, kinetic energy is EK. That's 1/2 mass times velocity squared. That's lunge. Okay, 1/2 times mass is 0.3 times our velocity squared. In the first case, the velocity is 4 meters a second. And afterward, it is going the same equation. It's 1/2 times our mass, 0.3 still, and our velocity now is positive 2. Really, this is negative 4. But whenever you square it, it's going to become positive. Okay, so what is that? 0.5 times 0.3 times 4 squared, negative 4 squared, 2.4. J for joules. On this one, 0.5 times 0.3 times 4. It's 2 squared is 4. 0.6 joules. The answer to A is no. It is not conserved kinetic energy. Okay, that's it. Okay. I was thinking there might be more. Number 8. A ball has a mass of 5 kilograms. Ball B has a mass of 10. Both are dropped from rest from a height of 2 meters off the ground. Compare their velocities right before impact with the ground. They both dropped from a height of 2 meters. Same. Compare their velocities, same velocity. We learned that whenever we talked about gravity. Same velocity if you're dropped from the same height. Compare their accelerations right before impact. Negative 9 meters per second squared. Compare their momentum. Okay, this is where we have to actually do something. So if it's dropped from 2 meters, then we know our equation for finding the time that it would take is this is a little shortcut. Just a second. Okay, so the t is h over 4.9, so square root of that, where the height in this case is 2, square root of 2 over 4.9, and that would give us second square root 2 divide 4.9, close parentheses, 0.64 seconds. Okay, if that's how long it takes, then their velocities would both be the acceleration negative 9.8 times time. The time is 0.64. Okay, so times 9.8, which is negative 6.26. Both of them. It's negative 6.26. Okay, so the momentum, ball A, I'll say PA is mass times velocity of mass A times velocity. And momentum of our B ball is mass of our B ball times velocity. Okay, so mass of our ball A, 5. Ball B has a mass of 10. They both can multiply negative 6.26, and you'll get your momentum. Okay, so that's number 8. Y'all can do the rest. There it is. I already did that one. Almost done here. I've only got maybe a few more. Number 10, number 12, and 14. A few more. Mass of A is traveling 8 meters a second, collides inelastically. That means it sticks. With mass B, which is traveling east at 4. Find the final velocity after collision. So they stick together. M1 V1 plus M2 V2 is mass 1 plus mass 2 times velocity. Mass 1. What is mass 1? Mass A is 10, going west at 8. Okay, so if it's going west, we're going to have to make that a negative 8. Plus mass 2 is 30 kilograms times negative 8, east at 4, so that's positive 4. That's 10 plus 30 times V. 10, that's negative 80 plus 120. That'd be 40 positive is 40 V. V equals 1 meter per second. Positive. Okay, since positive is going east, they're both going east. After collision, 30 kilogram swimmer runs 10 meters a second off the end of a dock into a 120 kilogram raft at rest next to the dock. Find the velocity of the swimmer and raft after the collision if they both move together. So that's an inelastic equation. So I'm writing the inelastic equation once again. Okay, mass 1, 30, times velocity, 10, plus dock onto 120, times at rest, 0. So basically we got 30 times 10, which is 300, equals, if we add their masses, that's 30 plus 120, which is 150. B. 150 is half of 300, so velocity would be 2 meters per second. Last one. Number 14, a 5 kilogram ball A, moves to the right at 2 meters a second and collides with ball B that was at rest. Find the final velocity of both balls if they collide elastically, they bounce off. Ball A has a final velocity of that to the left. Okay, so they bounce off. Here's your bouncing off equation. Mass 1, ball A 5, times right 2, which is positive 2, plus ball B was at rest, 0, equals ball A 5, final velocity of 1, plus ball B was 15. Okay. So V, we don't know how fast the ball B is going. All right, so let's solve it. 5 times 2 is 10, equals 5 plus 15 V. Oh, I missed something. Velocity 1 meter per second to the left. So I did catch it here. Negative 5. I caught it before we continued. Okay, so negative 5 plus 15b, we need to add 5 to both sides. So we have 15 equals 15b, and b equals 1. And that's to the right because it's positive. Last one. Oh, ball A, velocity A is 1 meter per second left. It says right here. And velocity of B is 1 meter per second right. All right, there it is. Compare the kinetic energy before and after collision. Okay. Ball A. Kinetic energy of ball A is going to be before the collision is going to be let's see, 1/2 mass times velocity squared, and then kinetic energy almost done of B before is 1/2 v squared, and of course we see that's 1/2 times mass. Mass is of our ball A is 5, and velocity of ball A we said was 2. Okay, so half of, what's that, 4 times 5? 4 times 5 is 20. Half of that is 10. 10 joules. Okay, on this one, well, it's not moving, right? The velocity is 0, so 0 joules. This is before. How about after? Let's see if I can fit after. After. So that's 1/2 times on ball A. Mass is still 5. And we have 1 squared. So that's going to be 5 times 1, which is 1. 1 squared is 1. And half of that is 2.5 joules. That's ball A. And ball B got a bit messy over here. That's all right. 1/2 times mass. It's all right for me. Hopefully it's all right for you. Mass is 15. Sorry about that. It's getting even more messy. And then ball B was going to the right at 1 meter per second. This one was negative. Okay. 15 times 1 squared is 15. Half of that is 7.5 joules. So if we added these two up, after we have 2.5 and 7.5, which is total of 10, right? After. And before, if we add 10 plus 0, we also have 10 joules. Kinetic energy was conserved. Okay, elastic collisions, kinetic energy is conserved. I think that's the point they were trying to get at on number 14. All right, so I did all the even ones for you. Hopefully that helps. Good luck on your test today, or whenever your test happens to be.